Okay, in today's screencast, I want to talk about survivorship curves. These are this is a method of graphing population dynamics in such a way that will allow us to visualize again the difference between K and R selected species. So, in a survivorship curve, what we're going to do is we're going to have a graph in which the x-axis is going to be time or age of organisms, and the y-axis is either going to be the number of individuals in the population or the percent of individuals in the population that are that particular age or have been alive for that much time. And so when we plot this, we see some interesting phenomena. So if we look at, and I apologize for my graphs, the software I use for drawing isn't that great. But anyway, so here's what we find. If we look at our selected species, what we find is that most of the individuals that are born there's just not that many of them by the time they reach a fairly young age. Okay, so like in this first few months of life or a couple years of life, the vast majority of them will die out, and there's just a few of them. There's a small number that are alive to an old age. Whereas if I look at a K-selected species, what I find is the majority of the individuals that are born are still alive as time goes by. That they didn't die early on in life. They get older and older and older. And it's not until they reach basically the biological limits of their lifespan that then their numbers begin to drop off. So I can look at these two very different curves and I can make an assessment as to what your reproductive strategy is. If I see this, you have lots of babies and most of them die before they reproduce. If I see this one here, I know that you invest time in your offspring, ensuring that they reach a reproductive age. So there's basically three types of survivorship curves. There is type 1, which is high survivorship. So we see here that of the 1,000 individuals born, as age goes by, they're still alive as they mature, and their numbers drop off when they get to old age. So they have a very high survivorship initially, and then a low survivorship once they reach an old age, a post-reproductive age. Let's go over and look at type 3. In a type 3, we have very low survivorship initially, and then a higher survivorship if you make it. So like those oysters that are born, the vast majority of them are going to die before they even get a chance to grow a shell. Once they do grow a shell, though, they tend to live out until they reach their maximum age that they can have. And then remember, this is a spectrum between K and R. So we find that type 2 has what we call a steady survivorship, that over time, the likelihood of surviving decreases at a pretty consistent rate. So those are the three types. We call it type 1, type 2, type 3 survivorship curves. And remember, this axis is going to be the number of individuals, and this is going to be the age of the individuals. Now, in order to make it work out, so if you think about it, a human typically can live to be about 100. A bird might live to be, I don't know, say 60, and a tree could live to be 1,000. So what we tend to do is we tend to plot the x-axis in a way that all the species, so this is relative to their total age. So rather than, if I want to compare different species, that is, if I'm trying to compare different species, I'm just going to say this is the maximum age we could expect for that organism. And so let's just compare what percentage of the offspring or how many survivors there are at a given fraction of that time frame. So for humans, we live to be about 100 years. Well, what you find is most humans survive, and by the time they're like 50, like halfway through their life expectancy, there's still quite a few of them. You get around 70, then the numbers start dropping off until you get that maximum age. Let's just call it 100. But with, say, a tree, the vast majority of the trees never get to, they don't really get established. They get eaten by squirrels or by deer, and they never get a chance to grow big enough. But those that do grow big enough, they last until the end. And then you have things like birds, which, there's pretty much a steady decrease in the number of individuals at a given age group from the infancy through the maximum possible lifespan. Now, if we're going to use numbers of individuals as our y-axis, it's often necessary to plot it as a logarithmic curve. And the reason is because we're often dealing with, if I don't, here's what happens. We're talking so many offspring. Let's say there's 100,000 offspring, very few of them survive. So it almost just looks like, like X and Y graph. I wouldn't even see the curve. In order to see that curve, though, if I plot it on a logarithmic scale where each set increment is an order of 10 difference. So from here to here is 10, from here to here is 100, from here to here is 1,000, and so on. When I graph it that way, I tend to see the changes that take place. So because this is especially necessary for the type 3 curve of R-selected species. So you often notice that we use logarithmic y-axes in order to be able to visualize the curve associated with these type 3 organisms. And again, like I said, since we have different lifespans, so we can have an insect might live to be 20 weeks, a guppy might live to be 60 weeks, an oak tree lives to be 1,000 years old, a human lives to be 100 years old. So it's best to do it in terms, instead of absolute time, it's best to do it in terms of percent of maximum lifespan. So if we do it that way, we get this lovely set of curves where this is the percentage of survivors on a logarithmic scale. This is the percentage of the maximum lifespan of the organism, regardless of what that lifespan would be. So take that maximum lifespan, like if it's 1,000 years, well, this is 500 years. If it's 100 years, this is 50. If it's 4 weeks, this is 2 weeks. And if we do it that way, we get these survivorship curves that are pretty often replicated. So again, a type 1 curve we associate with K-selected species that invest a lot of time helping their offspring reach a reproductive age. A type 3 curve is associated with R-selected species that don't do that. They just have lots of offspring and hope for the best. And then we have the in-between type 2s that follow something in between those two. Now, if we look at human population data, now humans are definitely a K-selected species, but given the circumstances in which people are raising their offspring, sometimes we find that circumstances are dire. There's disease, there's drought, there's famine, and that basically makes it more like an R-selected approach because you just have so many children, they don't survive to adulthood. So the solution is have a lot of babies and keep investing in them, but a lot of them may not make it. So these graphs are rather telling. So if we look at this one here, the bottom ones, this is basically 17th century England. And so what you see in 17th century England is that the percentage of children surviving, say the first 4 or 5 years of life, was very low. Like 25% of the population was dead before they made it to the age of 5. And if we consider, say, 15 to be the age at which people are able to reproduce, well, only 15% of the population was alive at that point. So if you look at that, it definitely looked like an R-selected curve, even though humans are investing time in their offspring. It's just there wasn't a lot of resources available. There's a lot of disease. So that was the strategy that people had to take. Now, if we look at modern Great Britain, now what we see is we have a much different one. We have very clearly a type 1 curve, and that's because, you know what, there's not much variation in the environment, that it's a safe place, it's stable, so your children are going to survive, so you can get this type 1 curve. And then we see here, this is Niger, and this is modern Niger, and this is an environment where there's still a bit of instability, and so as a result of that, we haven't achieved a type 1 curve, just because there's still a lot of variation that can affect the survival of the children. And so we end up with a curve that's more of a type 2 curve. Hey, thanks for watching. I think that's my last slide. Yep, thanks for watching. And we'll see you all in class next time we meet. That's going to be exciting. Bye.